Welcome to Introduction to Unit Testing with JUnit and IntelliJ. This video is for the students of CEN 3042, which is Software Development 1 at Valencia College in Orlando, Florida. This is Professor Evans, and I'm going to give you a quick and simple introduction to writing a unit test using JUnit and IntelliJ. So our learning objective for this video is that you will be able to set up a unit test for a very simple computational Java application using JUnit and IntelliJ. This is an introductory lesson for a student who is learning the software development process and learning how to write a unit test for the first time. By going through this video, you'll learn how to set up JUnit with IntelliJ, and you'll get a basic understanding of how to use an assertion statement to create your unit tests. By the end of this video, you should be able to take what's in here and extrapolate it to make it fit the particular application that you may be writing for one of your courses. So to begin, we're going to assume that we have an application called the Shape app. It is a very simple application written in Java. It's going to ask the user for the length and width of a rectangle. It's going to ask the user for the radius of a circle. And then it's going to print the area of the corresponding rectangle and circle. So it's a very basic application that is really just an introduction to classes and methods and how we create a class and invoke a method from that class. So our three classes within the Shape app are circle.java, which is used to create a circle object, rectangle.java, which is used to create a rectangle object, and shapeapp.java, and that contains our main method, which asks the user for all of the info, like length and width or radius, and it calls the appropriate method to display the area of that corresponding shape. So that's our application that we're going to be writing a unit test for. So let's quickly talk about unit tests. What we want to do is create a unit test that is going to verify that circle.java and rectangle.java have a method that correctly calculates the area of each shape. As a given, each class has a method called compute area. What we're going to do is write a unit test to verify that compute area does in fact calculate the area for each shape correctly. A little bit about compute area. It takes the shape's properties, length and width for a rectangle or a radius for a circle, and those are the arguments. Everything is input as double, and it returns the area, the corresponding area of that shape. So circle.java and rectangle.java each have a method called compute area, and it will take in those specific arguments, calculate the area, and return it back to the main program. So how are we going to write a unit test for this? Well, we're going to use JUnit in order to do that. JUnit, if you don't already know, is an open source framework used for writing and running software tests. Oftentimes, testing and coding are done by two separate teams. If you think about a large entity like a software company, a lot of times the person who tests the code is not necessarily the person who wrote the code. A test engineer will use a tool like JUnit to write a test for code that they didn't write. Ideally, what would happen is that the developer and the tester will end up with the exact same output when the developer runs their code and the tester tests that same code. Before the coder and the tester can begin, they both have to fully understand the software requirements, the use cases, what are the inputs and expected outputs, and then each entity would work separately on their assigned tasks. So once everyone understands the software requirements for the task at hand, the coder or the software development team will begin writing the code, while the test team will begin writing tests for that code. And neither one of these teams will kind of see what the other is doing. And at the end of the day, hopefully the software development team has developed a product that matches the requirements, and when the test team runs their tests, it will prove that to be true. So here's our unit testing methodology. Essentially, once our Shape app is written, we need to create a test class, and we have to ensure that JUnit is in your class path within your IDE. In this case, we're going to be using IntelliJ. And then within your test class, these are the steps that we're going to follow. I'm going to quickly go through this right now, but I'm going to switch over to IntelliJ and show you how this is done, and then we'll come back to this slide to review. But essentially what we're going to do within our test class is create an object that requires testing, supply test data to the object. We're going to look at a setup method to do that. We're going to create a test method and perform a method call for our object. Basically, that test method is going to be the method that tests our compute area method from our circle.java and rectangle.java files. And then we're going to use something called an assert statement to compare the output of the method call, meaning our compute area method from circle.java. We're going to compare the output of that to the output of our test data in our test method. And if our code is working correctly, those two values will be equal. So I'm going to pause here and navigate over to IntelliJ so that I can show you how to set this up and run this real time. All right, so now I'm in IntelliJ and I have my project open for the Shape app. So here's my Shape app. I'm going to walk you through our main method. So I have some variables, the rectangle length, the rectangle width, and the circle radius, which are all going to be doubles. I've also created a scanner object so that I can collect input from the user on the terminal. Then I'm just going to ask the user to supply the width of the rectangle and collect it in rectangle width. I'm going to ask the user to supply the length of the rectangle and collect that in rectangle length, and then ask the user to supply the radius of the circle and collect that in circle radius. After that, I'm going to create an object, one for the rectangle, one for the circle, and within my creation of that object, I'm going to supply the length and width for the rectangle as well as the radius for the circle. And then my output is going to just print a message to the user showing the corresponding area for each shape. So this is my main method. You can see here I have circle.java, which creates my circle object. My constructor shows that when a new object is created, the radius is set with the value that is supplied right here. And along with that, I have the appropriate get and set methods and then a method to compute the area. Same thing for rectangle.java. I have two variables, length and width, that are basically the components of my object rectangle. My constructor sets up that rectangle with a length and width. Then I have get and set methods and a compute area method at the bottom. Not going to go over too much the compute area methods because right now I want to test that those work. So let's just assume that we're looking at a piece of code that someone else has written, and we are going to test that the compute area methods for both rectangle and circle supply the correct output. So in order to get started with writing your unit test, the first thing that you want to do is go into the class that you want to write a test for. I'm going to start by writing a test for rectangle. And you're just going to click the line where your class is declared. In my case, it's line 8. You're just going to put the cursor on that line in front of the class that you want to write a test for. And on your keyboard, hit Alt-Enter. And this menu will come up. And we're going to hit Create Test. Now, if you've never done any test files before, you're going to get this message asking you to create the test in the same source root. Click OK. This window will come up, and you want to make sure that the testing library is set as JUnit 5. And then we're going to give it a name. In this case, I'm going to name it Shape Test. I'm going to include a setup method, and I'll explain what we use that for in a few minutes. And then below here, it's going to pull all the methods in that class and ask you which ones you want to generate a test method for. In this case, I don't need to test my getter or setter methods. I just want to test the compute area because that's really the meat of this program. Is the area calculated correctly? I want to test that. So I'm going to click this box to include the fact that I want a test method for the compute area method within this class and click OK. If you have your IntelliJ connected to your GitHub, it's going to ask you if you want to add your file to Git. I'll do that later. And this is what I have showing up right now. Notice that I've got some red lines that tells me that a library is missing. If I click the red line here, and you'll notice that it's going to ask me if I want to add JUnit to the class path, and we do. In this case, we're using JUnit 5, so we're going to go ahead and add JUnit 5.8.1 to the class path. And it's going to ask you to download the library. That's fine. You're just going to click OK. Once I've done that, all my red goes away. And now I'm good to start writing my tests. So when we write a unit test, we have to make sure that the test is linked to JUnit and that JUnit is added to our class path. If that's done correctly, you are going to see it listed here in your external libraries. So if you are doing this on your own and you notice that your import statement has a red line in it or some of your methods have turned red, that means that it cannot find the API for JUnit and it's not added to your class path. So you have to correct that. So now that this is in my class path, I'm ready to start writing a test. So the first thing that I'm going to do within my Shape app is create an object that I want to test. In this case, I'm going to test the rectangle object first. So I'm going to create an object called rectangle. And in my setup method, this is where I'm going to supply some test data. If you'll notice here, we have void setup. And basically every time you run this test, before it actually tests your method compute area, it's going to run whatever's in here first. It'll run whatever code you put in here when you execute each test. So before I start the test, I want to make sure that my rectangle has some data. I want to make sure that my rectangle has a length and a width so that when I test the compute area method, I can test a shape that has some dimensions. So this is where I'm going to supply test data to a rectangle object. So I am going to call the constructor now, and I'm going to give the rectangle my own data. So let's say that I've decided that the length is going to be 10 and the width is going to be 5.5. That's what I'm picking. So as the person running the test, I'm able to choose the data I want to supply. In this case, I'm going to give it these two values. Down here, this is the method that is going to test compute area. So I have a compute area method inside my rectangle.java class, right down here. I have a compute area method, and I want to test to make sure that the output is correct. In this case, just to avoid any confusion, I'm going to call this compute area test _ rectangle. Just going to change that name there. And I'm also going to add a command here. This command right here will allow me to see what test I'm running within the terminal if the test were to fail. Notice that I have some red here, so I'm going to hit Alt-Enter to import this class. And you'll notice right up here, it's imported and no longer red. This class is just a part of your JUnit API. But display name allows me to display a message on the terminal in the event that the test should fail. Then I know what test I was running when something failed. It's a good idea to just label your test this way. All right, so now we're going to check that compute area for rectangle works correctly. So using our own test data, compute the area of the rectangle. So we're going to pretend that we didn't already know how the compute area method was already written. We're going to pretend that someone else has written rectangle.java and circle.java. We're going to pretend we don't know what's already in there. If someone were to write an application with a method that computes the area of a rectangle, we know that the area should be length times width. So we're going to use our own test data and say, well, according to the object we created, if I take the area of this rectangle, it would be length times width. So we're going to compute our own area first. So I have double rectangle area equals, and then I am going to say, well, the area of my rectangle should be rectangle length times rectangle width. Again, when I call this, I am calling the object I created and then instantiated right here. So I'm going to basically calculate the area of this rectangle and store it in rectangle area. Now I'm going to use a statement called assert equals. So assert equals is a part of your JUnit API. There are many different forms it takes. You can actually look through these and look at the types of inputs that you can supply. The output is always void. Assert equals is going to take two arguments and compare them to see if they are equal. If they're equal, the test will pass and you won't really see anything on your screen. But if they're not equal, you'll see an error message on your terminal letting you know that the two values weren't equal. So I'm going to add a comment sort of explaining that up top. Assert equals will compare two values and display a message if they aren't equal. So what I want to compare is my test data. So I want to see if the test data that I generated is going to be equal to the data that comes out of the compute area method. So again, if I go back to rectangle.java, I want to know that this area is returning the right value. So I want to compare my own test data to the compute area method in my rectangle class. So the first two arguments in assert equals are the two things we want to compare. The first thing is what we expect to come out. The second thing is what actually comes out. So we expect the area to be this value. What's actually going to come out is this value. If these two things are not equal, we want to display a message to the screen. So the message is your third argument. And so you can see it says message right there. So if I did not get the same value, what would I want to send to the terminal? I'd want to send some sort of error message. Okay, this lets me know as the tester, okay, my test failed. And I know exactly where it failed. It failed in this method, and I know what the problem was. So this is a very simple demonstration, but if you were testing a more complex application, you would want to make sure that you use your messaging features within JUnit to help you know exactly what failed, when, and perhaps why, depending on your application. So I have a message here that will display if these two values don't match. And now I'm ready to run my test. So I'm going to go ahead and run this. Notice that my shapetest.java is red. If your file name is red in IntelliJ, it's just letting you know that your file is not currently backed up to your Git, which I didn't do at the beginning. I'll back it up to my Git at the end of this video. So we can ignore the red file name here. We're going to go ahead and run our shapetest.java and look at what comes out. So in this window here, we can see the test file that we were running and the tests that were included in that file. There was only one test, and it says that the test passed. So our assert equal statement actually came out to be true. Basically, the rectangle area here was compared to the area you get from our compute area method, and they match. Now, let's say that for whatever reason, I accidentally replaced the multiplication sign with a plus sign here in my compute area method. So I've written my rectangle class, I have my constructors, my getters, my setters, I have my area method, and I think it works perfectly. And then I connect it to a unit test where perhaps I have a teammate or a partner who writes the unit test. And so this is what my teammate or partner might write to test and make sure that I computed the area correctly. Now we should see that our test is going to fail because the way that our test data is set up, our test data is going to calculate that area by multiplying the length and the width, but our actual method doesn't do that. Therefore, we should get two different values here, and assert equals should say, hey, there's a problem, and it's going to display our message. So let's see that in real time by running our shapetest.java file again. And now we can see that our test failed. And the area of the rectangle is incorrect. There's the message that is displayed, letting me know, okay, something went wrong. And it tells you even right here, what was the expected area? The expected area was 55. 10 times 5.5, our expected area was 55. That's what we should have got. What we actually got was 15.5. That tells me, as the tester, that this method doesn't work correctly, and that someone has to go back into this method and fix it. In this case, we know what's wrong with it because we just broke it, but that is how you'll know that the test failed. It'll be very obvious within this window that something wasn't right. I'm going to go ahead and put compute area back together, and then I'm going to run it again, and we'll see that that error disappears. And it's back to working correctly. So now we're going to repeat this idea except for the circle. So I need a circle object. I need to supply test data to that circle object. Oops, there we go. And I'm going to give it a radius. So let's say I give it a radius of 7.5. Capital letter. All right, so I have my new circle and my new rectangle here instantiated with my test data. Now I'm going to, I could write another method that computes the area of the rectangle. So I could write another method, or I could also compute the area of the circle within the same method. So it's kind of up to you. If you want two different methods, then I could copy paste this. I'm going to change this to circle and change this to circle. I'm going to change this to circle area. And in this case, I know that the area of my circle is going to be circle.getRadius. We're going to do the radius squared, so I can just multiply the radius by itself. Or there are other options, but you can pick whatever works for you. And then I'm going to have times math.pi to get my circle area. And this time I'm going to assert equals. That circle area is equal to circle.compute area. And I'll update my message. So now I have two different tests that I'm going to run within my shape test file. So let's go ahead and run this. Now I can see the two tests that I created are here, and they both worked properly. Let's say that my test data is wrong this time. Let's say that I did not have the correct formula for calculating area in my test data. Let's see what happens. All right, so now we can see that my 2 tests ran. Compute rectangle passed, no issues. Compute circle. This one failed, and our expected and our actual don't match. So at this point, as the tester, I might say, oh, this person didn't write their area formula correctly, but in actuality, it was the tester's error right here that caused this to fail. And I make that point just to say that you, as the tester, have to ensure you know the correct outcome and how to achieve it, because sometimes a test could fail because your test was testing the wrong way or the wrong thing. So be very careful about setting up your test. This is why it's so important to understand software requirements, understand how outputs are supposed to be generated, because a bad test doesn't necessarily mean that your code is bad. So we want to make sure that when we test, we have the right frame of mind and we have the right understanding for how we are going to develop our test data and develop our expected outputs from any application that we are testing. So in this case, our test data is what's wrong. And over time, a good software engineer will be able to understand those nuances and those differences of how to make sure that you have a good test and also that you have good code that is written within your application. So I'm going to go ahead and put my circle area back for my test data. And now we can see that our 2 tests are passing once again. So going back to that unit testing methodology slide, this is what we did essentially with that small example. We created an object that requires testing. We created a circle object and a rectangle object. We supplied test data to the object. We used the setup method to do that. Then we created a test method and we performed a method call for the object. In this case, we wanted to test the method compute area for the circle object and the rectangle object. So we did that within each test method. And within the test method, we used that assert statement to compare the output of the method call to the test data. So in general, when we write our unit tests, we want to remember, or we want to always consider, the expected output, which is from your test data, compared to the actual output from your method call. And this is essentially how we set up unit testing. What I would encourage you to do is check out the JUnit assert class so that you can review other assert methods that you can use with the JUnit API. For example, we did assert equals. There's also assert not equals, assert null. There are other things you can assert and check for. So you'll want to review the documentation for JUnit to learn what else you can do with that assert class. And that wraps up our introduction to using JUnit for writing a unit test. If you have questions, you can always email me at aevans57@valenciacollege.edu. My contact information is here on the screen. Hopefully this video will get you started with learning how to set up a unit test. My advice would be to use this video to test something very simple and then gradually add complexity as you understand how to use JUnit. Thank you for watching. Until next time.